we are going to practice quantitative reasoning data sufficiency topic, and in that we are going to analyze linear equations, number properties, and dealing with two variables and logical deduction. So for the first question, we have what is the price of an orange, and we are given two statements. The price of 3 oranges and 2 apples is $7. So let price of orange, it is given as, so it is not given, so we'll take it as X, and price of apples, we'll take it as Y. And we are given a statement that price of 3 oranges and 2 apples is $7. So 3x plus 2y gives us 7. So this is the first equation. And the statement 2 is given as the price of an orange and the price of an apple are both integers. So we have to calculate the price of orange and price of apple. So the options given are alone, statement 1 alone is sufficient, but statement 2 alone is not sufficient to answer the question. Statement 2 given is statement 2 alone is sufficient, but statement 1 alone is not sufficient to answer the question asked. The next option given is both statement 1 and 2 together are sufficient to answer the question, but neither statement alone is sufficient to answer the question. And the second last option given is each statement alone is sufficient to answer the question asked. The last option given is together both the statements are not sufficient to answer the question asked, and additional data specific need to the problem must be given. So the answer would be both statement 1 and 2 together are sufficient to answer the question, but neither statement alone is sufficient to answer the question asked. So why? And we are given that X and Y both are integers. We are given this is given. So what we can find out is for the price of an orange, which is X, we can calculate 3x gives 7 minus 2y, and dividing both sides by 3 we get this. So this is the price of an orange with respect to price of an apple. So while we keep on putting values of y as 0, 1, 2, 3, we get that for y equal to 0, x is 7 over 3, which is not an integer, so it is not a correct option. For y equal to 1, we get 5 by 3, y equal to 2, we get x as 1. So I think this could give us our answer, because as we are increasing the values of y, it is going, the value of x is coming as negatives, and obviously the price of a fruit cannot be negative. So I think both statements should be together given to answer the specific question. So for the next question, a trader purchased 3 products, product X, product Y, and product Z for a sum of $500,000. So X plus Y plus Z is given as $500,000. And we are asked, did the trader pay more than $200,000 for the product Z? And we are given two statements. The sum the trader paid for product X and Y combined was 3 times the sum the trader paid for product X. So X plus Y is equal to 3x. And the second statement given is the trader purchased more to purchase product Z than to purchase product Y. So Z is greater than Y, like this. So let's try to solve. So Y would be equal to 2x, and if you make an equation, because we are given that the trader paid more to purchase product Z than to purchase product Y. So if we convert this equation into two variable, which would be Y and Z, we could solve up to a level. So it would be X is Y by 2 plus Y plus Z is equal to $500,000. 3y by 2 as z equal to $500,000. So if we subtract z from both the sides, multiply by 2 on both sides and divide by 3, we get this y. Okay, and we are given that z is greater than y. So this equation, write it as this. Like this. We got an inequality, and if we try to solve that, we get z is greater than $200,000. We get this. So both the statements are alone not enough to answer the question, but together these statements are sufficient to answer the question. Let's move on to next question. The next question is, a teacher distributed pens, pencils and erasers among all the students of his class, such that all students got an equal number of pens, an equal number of pencils and an equal number of erasers. If no pens, pencils or erasers remain with the teacher, how many students were there in the class? So the first statement, now it is given. Each student got pens, pencils and erasers in the ratio 3:4:5 respectively. The teacher distributed a total of 27 pens, 36 pencils and 45 erasers. So what's the ratio? Let pens is to pencil is to eraser be x is to y is to z, which is equal to 3:4:5. So if we take, we should not consider the ratio as same it is, because it could also be 27:16:25, which is also the same as 3:4:5. Hence we consider the ratio as 3k:4k:5k. K is some constant here. And given as the teacher distributed a total of 27 pens. So number of x is 27. So number n into x is 27. The students into number of pens is 27. So and n into y is 36 and n into z is 45. So even if we combine the equations, we get nx equals to 27 is equal to 3k from this equation. So k would come as 9 and n would come as 3k by x. So we have two unknown variables, but we do not have any proper equations to solve this question. Hence both the statements are insufficient to answer this question. So let's move on to the next question. So now we are given, if neither x nor y is equal to 0, is 3x minus 2y equal to 0? This. We have to answer this question, and we are given, statement 1 is given as 27x cube minus 8y cube equal to 0, and the second statement is 9x square minus 4y square equal to 0. So if we solve this equation, we get 27 over 8 as y cube over x cube. So if we reverse this equation, we get x over y as 2 over 3, and if we take values of x as 2 and y as 3, so if we put into this equation, we get the answer that yes, this equation equal to 0. So statement 1 is sufficient to answer this question. But if we take statement 2, we would get 9 over 4 as y square over x square. So y over x would be plus minus 3 by 2. y plus minus 3 by 2, remember that root y square is equal to plus minus y. It could be plus, it could be minus. It is not always equal to y. It could be equal to y but not always equal to y. So we can get two values here, y over x as 3 by 2 and y over x as minus 3 by 2. This would satisfy the equation, but this would not satisfy the equation. Hence we can say that statement 2 alone is not sufficient to answer this question. Statement 1 alone is sufficient to answer this question. Okay, so let's move on to the next question. So the question given as, did David solve more questions than Steve in a 2-hour test? So the statement 1 given as, thrice the number of questions that David solved in the test was greater than 6 less than thrice the number of questions that Steve solved in the test. So let David solved x questions and Steve solved y questions. Okay, and thrice the number of questions that David solved in the test was greater than 6 less than thrice the number of questions that Steve solved in the test. So 3x would be greater than 3y minus 6. Statement 1. Second statement is, twice the number of questions that David solved in the test was greater than 4 less than twice the number of questions that Steve solved in the test. So 2x is greater than 2y minus 4. But if we look at one thing, if we solve it further by dividing both sides by 3, we get x greater than y minus 2. Okay, if we divide both sides by 3, and here if we divide both sides by 2, we get x as y minus 2. Both of these are same equations, same inequality, sorry. Both of these are same inequalities. Having only one inequality, how can we solve this question? So answer would be, statements 1 and 2 together are not sufficient to answer the question asked, and additional data needs to be specified. So let's move on to next question. Next question given is, a box has at least one ball of each of the colors red, green and blue, and no balls of any other color. If one ball is drawn randomly from the box, is the probability that the drawn ball is red same as the probability that the drawn ball is blue, but not the same as probability that the drawn ball is green? So statement 1 given as, there are 5 balls in the box, and the statement 2 given is, the number of green balls is greater than the number of blue balls. So the total number of balls are 5. And we are given as the number of green balls is greater than the number of blue balls. So green balls is greater than the number of blue balls. This is given to us. And we need to find whether the probability of drawing a red ball, so let the probability of drawing a red ball be P of R, is equal to probability of drawing a blue ball, so P of B, but which is not equal to probability of drawing a green ball. So which we could conclude from this statement that it could also mean that the number of red balls is equal to the number of blue balls and is equal to the number of, not equal to the number of green balls. Okay, so number of red balls is x equal to y and not equal to z, like this. So if we take some like random values, we could get 3, 1, 1. So here the probability of red and blue balls is equal, and the probability of green ball is not equal to them. But in another case, if we take it as 2, 1 and 2, because we are not given any condition about red and green balls, whether they are equal, greater or less. So this could also be a condition. Here probability of this is red and blue are not equal, but probability of red and green are equal. Hence, we could conclude that these statements are insufficient to answer this question, and we would require more data to answer. Okay, so let's move on to the next question. So for all integers n, the function f is defined by f of n equal to a 6 over n, like this. And we need to find the value of f of 1, and we are given f of 2 as 64 and f of 3 as 16. This is given to us. We need to find the value of f of 1. So if we put 2 in this equation, we would get f of 2 as a cube as 64 and a would be equal to 4. So from this f of 1 can be 4 to the power 6. Okay, we got f of 1. It's a big number, but we can still calculate this. And from we are given f of 3 as 16, so f of 3 would be equal to a square as 16, so a would be 4 and f of 1 would be still 4 to the power 6. So both statements 1 and 2 alone are sufficient to answer this question. Let's move on to the next question. So the next question, if no bulk purchase discount apples applies, what is the price of 13 oranges and 12 apples? So the price of 39 oranges and 36 apples is $111. So 39x plus 36y is given as 111. Okay, and the second statement is price of 3 oranges and 12 apples is $7. 3 oranges and 2 apples is $7. We need to find the price of 13 oranges and 12 apples. So in this statement, if we divide both sides by 3, we get 13x plus 12y as 11 by 3. So which would be $37. Hence, we found the price of 13 oranges and 12 apples. So, statement 1 is alone sufficient to answer this question, but statement 2 alone is not sufficient to answer this question. So, let's move on to the next question. So, the next question given is the price of 3 apples and 3 apples and 3 mangoes is equal to 6. So 3x plus 3y is equal to 6. First statement given is this. And the second statement is the price of 1 mango and 1 apple is equal to 2. This. Find the price of 3 apples and 2 mangoes. 3 apples and 2 mangoes. This. So how do we solve this further? Seeing this equation, we get x plus y equal to 2, and if we divide both sides by 3 here, we get x plus y equal to 2. So these two are again the same equations. It is the same type of question which we did earlier. Hence both the statements are insufficient to answer this question. Hence we cannot answer this question. We need more data to answer this question. So thank you for watching the video.